This is the first video on Chapter 32, Implicit Differentiation. And you'll notice when you turn to this chapter, there are no definitions, there are no theorems, there are only examples. And what I usually tell my students in class is the reason for that is you already know how to do these problems, you just might not know that you know how to do them. So, when do we use implicit differentiation? Why do we use implicit differentiation? Well, let's look at this curve. This curve here is clearly not a function, right? It miserably fails the vertical line test. It still could have an equation of x and y together, similar to this equation right here. There is an x and a y together, but it is not, we don't have y explicitly defined in terms of x. But if we look at this little piece of this graph right here, it is a function, right? It passes a vertical line test on this little piece. And so on this little piece, we can find the rate of change of y with respect to x. We can find the slope of the tangent line at some point xy. The problem is we don't have a function of y in terms of x. Even right here at this point, it fails the vertical line test. So what do we do about that? We have a similar situation with a circle. Circle's not a function. Now, the top half of a circle is a function, the bottom half of the circle is a function, and so if we wanted to, we could solve for y in terms of x for the top half or the bottom half, whichever half we need to, and then we have y as a function of x, and we can differentiate, we can take the derivative of y with respect to x. Just explicitly. But I think we're going to find when we look at part C of example 253 that even with a circle where we could express y as a function of x, it's going to be easier not to. So let's look at example 253 part A. We have this equation of x and y. And what we want to do is we want to find the equation of the tangent line to this curve at the point -1, 2. That is our job. So we take the derivative with respect to x of both sides. And here's where we have to be careful with implicit differentiation. Y is a function of x on the part that we're looking at. So we have to tell ourselves y is a function. X is the variable we're differentiating with respect to x. So it's the variable we're differentiating with respect to. Y is a function of x. So we have to treat it like a function. That means we have to use the chain rule. So we take the derivative of x squared times y cubed. We use the product rule. We take the derivative of the first term times the second. And now we have the first term, which is x squared, times the derivative of the second. So now we take the derivative of y cubed. The derivative of y cubed is 3 times y squared times the derivative of y with respect to x. Remember, we're differentiating with respect to x. Y is a function. So the derivative of y cubed is not only 3y squared. It's 3y squared times y prime. Then we take the derivative of x squared, which is 2x. Remember, we're differentiating with respect to x. So the derivative of x squared is simply 2x. The derivative of y is not 1. The derivative of y is the derivative of y. So remember, y is a function of x. So we have to treat it like a function. So the derivative of y with respect to x is not 1. It's a derivative of y with respect to x. So now we have an equation with 3 variables, x, y, and y prime. We solve for y prime in terms of x and y. And now we want to write the equation of a line. What do we need for the equation of a line? We need an x-coordinate, a y-coordinate, and a slope. X-coordinate we were given in the problem, if you look up here. The y-coordinate we're given in the problem. We need the slope. Well, as it always is, the slope is the derivative. So the slope is y prime. How do we find y prime? Well, here's y prime in terms of x and y. We're given that x is -1 and y is 2. So we substitute -1 for x, we substitute 2 for y, and we simplify this. So y prime is 18/13. So the equation of the line, y minus the y coordinate is equal to the slope multiplied by x minus the x coordinate. And so we have x minus -1, which is x plus 1.